When our rational expression has monomials for its numerator and denominator, the fastest way to simplify them is to think of what we're doing as using the quotient of powers rule and just going through one variable at a time and taking the quotient of the powers. Remember, the quotient of the powers rule for positive integers, which is what we want here because we're dealing with monomials, is if the exponent in the numerator is greater, we take the exponent in the numerator minus the one in the denominator. If we still have a fraction, the result ends up in the numerator. If the exponent in the numerator is less than the one in the denominator, we take the exponent in the denominator minus the one in the numerator, and the result ends up in the denominator. We'll go through and apply this to each variable, and we can also cancel common factors of any numeric coefficient. So here we have x to the third, y to the third, z, over x to the third, y, z to the fifth. So I'm going to go through one variable at a time. For my x's, the greater variable is in the denominator. So I'll have x to the power 3 minus 2. For my y's, the greater power is in the numerator. So I'll have y to the power 3 minus 1 in my numerator. And then for my z's, the greater power is in the denominator. I'll have z to the power 5 minus 1 in the denominator. So that gives me, as my numerator, y squared. As my denominator, x to the first power is just x, then z to the fourth. Let's see a second example. Here I have 3 times a squared times b to the fifth times c over 9 times a squared times c to the fourth times d squared. Now the first thing I notice is that I just have identically a squared in the numerator and denominator. That's a common factor. I can cancel it. As for numbers, in my numerator I have a 3. In my denominator, 9 is 3 times 3. So I'll have a factor of 3 that cancels there. Next, I'm going to look at b. B appears only in the numerator. Nothing cancels with it. I'll have a b to the fifth in the numerator. Looking at c. C appears both in the numerator and the denominator. The larger power is in the denominator. So in the denominator, I'll have c to the power 4 minus 1. And then d appears only in the denominator. Nothing to cancel with that. I'll have d squared in the denominator. So what does that leave me with? I'll have just b squared by itself for my numerator. In my denominator, I'll have a 3. I'll have a c to the power 4 minus 1 is 3. And then I'll have that d squared. And that's it. Now, we can do the same thing when we have negative powers of our variables. They aren't strictly monomials, but we're going to mention this here. Because even though these aren't actually monomials, it's the exact same technique. So here I have x to the negative 3, y squared, z to the fifth, over x squared y to the negative 4 z cubed. And just like with the positive integer exponents, I'm going to go through variable by variable. So I have x to the negative 3. I have x to the 2. 2 is greater than negative 3. So I'll have x to the 2 minus negative 3 in my denominator. For my y's, I have y to the power 2 in the numerator, y to the power negative 4 in the denominator. 2 is greater than negative 4, so I'll have y to the power 2 minus negative 4 in my numerator. And then for my z's, I have z to the 5th, z to the 3rd. 5 is greater than 3, so I'll have z to the power 5 minus 3. Okay, where does that leave me? Well, for my numerator, I have y to the power 2 minus negative 4 is positive 6. And then I have z to the power 5 minus 3 is 2. In my denominator, I have x to the power 2 minus negative 3 is 5. When I had a variable with a positive power that appeared in only the numerator or only the denominator, I just left it alone and copied it. When I have a variable with a negative exponent that appears in only the numerator or only the denominator, I'll switch where it appears and give it a positive exponent. So in this last example, I have 4 times a to the negative 3 times b over 5 times b to the negative 2 times c to the negative 1. 4 and 5 have no common factors, so I'll just copy those. A appears only as a to the negative 3 in the numerator, so I'll make that an a to the positive 3 in the denominator. B appears in the numerator as b to the first power, in the denominator as b to the negative 2. 1 is greater than negative 2, so in the numerator I'll have b to the power 1 minus negative 2. And then c appears only in the denominator with a negative 1 power. That'll become c to the power positive 1 in the numerator. Okay, what does that leave me with? For my numerator, I'll have 4 times b to the power 1 minus negative 2 is positive 3. And then c to the power 1, I'll just write c. For my denominator, I have 5 times a to the 3rd. So ratios of monomials, we just use the exponent rules, and even though they're not strictly speaking monomials, we can work with products of powers of variables that include negative powers of variables in exactly the same way.